Okay, let's do example of test 3. So question number 1. Simple linear regression results. So all this information is given. Here we have speed, sample size, correlation, R squared, so and all parameter estimate, analysis. So let's see the question. The Pearson correlation coefficient R. Pearson correlation coefficient, this R is here 0.922. Let me see how many decimals they want. Oh, answer is given. We need to choose it. That's better. 0.9224. Here it is. Okay. Indicate that. So 9224 meaning it's a strong because it's close to 1, right? Pearson correlation, the varying between 0 and 1. So 0, it's less than 50%, it's going to be very weak. Around 50%, 60%, 70%, it's going to be moderate, and behind of that, it's going to be strong. In our case, it's strong, it's over 90%. And so evidence of a strong, of what? Positive, because it's positive, right? Linear correlation can be negative also. Positive linear relationship between height and speed of roller coaster sampled. Okay, question number 2. Here we have, I'm not going to even read the problem. What we have here, the table and all information here. But our question is, use these results here in this problem, use these results to estimate the weight in pounds of a male teenager who is 84-inch tall. Round the answer to 10th or 1 decimal place. Okay, where is our equation for weight? Here it is, negative 171. Let me take a picture so I can put it there. Actually, I can do it on my calculator right here. Is this equation, it says weight is negative 171.53854 plus 4.8317 blah 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 times height. And this height is given here 84 inches. So to figure it out of how many pounds will be 84 inches tall, we are going to take this 84 and multiply by this 4.17653. As you can see, I'm not rounding anything during the calculation, and minus 171.53 854. Now, pay attention. I did minus because it's negative. If it would be plus, then I would add it, obviously. And I got 234.3. Let's see. 234.3. That is our height. Okay. Next. What is this? Oh, okay. I thought it's related to problem. Next. Question number 3. The term statistics refers to a population quantity and the term parameter refers to a sample quantity. And it is the opposite. The term statistic refers to sample quantity, and the term parameter refers to population quantity, which means this is false. There also in as question 3, you possibly can have the fact that the central limit theorem is important in statistics because for a large sample size n, it says that sampling distribution of the sample mean it's approximately normal. So one more time, there can be, instead of this question, can be also a question that the why central limit theorem is important in statistics, because when the sample size is large, we can approximate to normal distribution, regardless what type of population it is. And large meaning over 30, amount of 30, okay? Okay, question number 4. In local Eat Pizza restaurant, want to investigate the possibility of starting delivering pizza. Okay, the owner of the store has determined that home delivery will not be successful if the average time spent on a delivery is more than 34 minutes. Okay, so the owner of the store has determined that the home delivery will not be successful if the average time on a delivery is more than 34 minutes. The owner has randomly selected 24 customers and delivered pizzas for their home. The average delivery time of the sample was 34.8. What hypothesis should owner test to demonstrate that pizza delivery will not be successful? Since it's asking for the case when pizza delivery will not be successful, so where is description of the case when delivery will not be successful? Here it is. The owner of the store has determined that home delivery will not be successful if the average time that already tell us we're using mu, average time is more than 34. So this is null hypothesis. More than 34, equal sign is missing, right? It's greater than 34. That means it's given alternative. Mu is greater than 34. And accordingly, null hypothesis is going to be equal 34. Okay? Question number 5. A politician claims that 70% of his constituents favor a new ball pack. So we need to identify right tail, left tail, low tail. So if it says that 70%, that means is 70%, that identify two tail, is always 70%. If it would says less than 70% or at most 70%, that means left tail, because it's a less, side of less. If it would say more than 70% or over 70%, that would be our right tail. Question number 6. Given mu is less than 20, for which confidence interval should you reject null hypothesis? Okay, let's do this. Mu is less than 20. Alternative is mu is less than 20 or 0.2, I'm sorry. Okay, 20. Okay, that doesn't matter. 20. Okay, less than 20. Okay, if less than 20, then null hypothesis, it's going to be greater or equal 20, right? So to be able to reject, right, is that what it's asking? Or it should be reject. Okay, null hypothesis. To reject null hypothesis, so everything has to be less than 20, so we would reject null hypothesis, correct? So our confidence interval that has to be less than 20. Let's go back. Which one is less than 20? This one. This one is the one that we are going to reject null hypothesis. All right. Next. In a test of alternative hypothesis P is equal 0.4 against alternative P is not equal 0.4, that is our two-tailed test. The sample data yielded the test statistic Z is equal 2.04. Find the p-value for this. Since I already solved the problem for z-score is equal 1.52, so I'm going to work with z-score equal 1.52, right? It's recording dropped and I reinstated, and now it's showing 2.04. So I have already recorded the same problem with z-score equal 1.52. So as you can see, it's no difference. Just same way you're going to work with 2.04, just to avoid re-recording everything again. All right. So I'm going to use the same z-score calculator, calculator.net, that you have for your homework. And because to find probability p-value, we need to put test statistics z-score equal 1.52. Here it is, 1.52. Go. And which one we're going to pick? Because we have a two-tail test. That means it's going to be the last one, two-tail test, meaning, let me explain real quick. Two-tail test meaning this tail and this tail. And that is going to be the last one, 0.12851. So 0.12, let me see, 0.128, how much? 851. 12851. Okay. So you have to be careful if it's give you the tail you identify based on alternative. If alternative would say proportion is greater than, then it would be right tail. If alternative says less than, then it is left tail, okay? And then you will pick up accordingly. For left tail would be 0.93574. Right tail would be right tail would be 0.064255. Okay, and two tails the last one. All right. Next question. The alternative mu greater than 40 and p-value is given. Okay. Do you reject or fail to reject null hypothesis at alpha equal 0.01? Okay, how are we gonna identify? We are going to compare p-value to alpha. Okay, if our p-value is greater than alpha, then we fail to reject. Why? Because, let me show you here. If we have left tail, this is our alpha. So if my p-value fall here, which means greater, then we fail to reject. If my p-value falls within where alpha is, then we reject it. Now, our alternative hypothesis, mu is greater than 40, which means since we are interested in the answer for null hypothesis, that means if alternative is greater than, let me see, if our alternative is greater than, then null is going to be less than, right? So which means if our p-value is less than alpha, then we are rejecting. If our p-value is greater than alpha, then we fail to reject, which means it's going to fall in this area. Okay, and this is for null hypothesis. Okay, so let's go back and see. Since we have null hypothesis is going to be less or equal, in that case, our p-value, if it's less than, we are rejecting. But if it's greater than, in our case 0.04 is greater than 0.01, then we fail to reject. Okay, question number 9. Using z distribution, find the rejection region of for a two-tail test with alpha 0.05 and n is equal 74. So since it's z distribution, just alpha, it's going to be enough, because based on alpha we will find our z-score, z distribution. So let's see, let's plug it here in our z-score, 0.05. Since it says to tail, right? Let me double check. Yes, to tail 0.05. Okay, so, and this is to tail because left tail and right tail, less and greater than. We calculate and we are getting 1.96. 1.96, it's going to be either less than the negative 196 or greater than 1.96, and this is going to be our rejection area. Okay, question number 10. Find the critical value for sample with n is equal 23, alpha equals 0.01, if alternative hypothesis is less than 71. Okay, how are we going to work with this problem? Since we have n is equal 23, it's less than 30, then we are going to use, instead of z-score, we are going to use t-score. Okay, so let me open t-score. Here it is. I tried to find calculator, but it gives difference with your problems a little bit. So this is the table that matches to your answers in the given test. So this is how we're going to work. Vertically, we have degree of freedom. See here, the F here on the left side. The F, degree of freedom, that degree of freedom is equal sample size minus 1. Degree of freedom is equal n minus 1. Okay, and on the horizontal line in the title, we have here cumulative probability, where that's giving you percentage, and one tail and two tails. So if it's two tails, we're going to take lower line, or one tail upper line. So in our case, what do we have? We have less than 71, we have left tail. So we need our alpha 0.01 and our sample 23. If sample size is 23, that means our degree of freedom will be 22. And we need alpha 0.01, one tail. So 22, degree of freedom 22, here it is. And I'm heading to, horizontally, I'm heading to alpha that is equal 21. So 0.01, one tail, here it is, 0.01. I'm coming down 22, 2.508. This one, here it is, because 0.01, this is gives us a confidence interval T99, T.99%, 0.99 or 99%, and one tail 0.01, two tail 0.02. This is this vertical line, and I'm coming down to 22. I'm getting 2.508. Here it is, 2.508. Okay, 0.508. Oh, I forgot. In question 10, put negative 0.508 because it's a left tail test, right? Alternative 1 is less than, null alternative is less than, so it's going to be negative 0.508. Okay, question number 11. Determine whether the normal sampling distribution can be used. The claim is P is equal 0.9 and the sample size is N is equal 40. So what we have in this case, we are going to use not normal distribution. You know why we don't use normal distribution? Because our multiplication P times N, remember from homework chapter 8.2, I think, we had to satisfy condition N times P has to be greater or equal 10. In our case, it's going to be 3 point, it's going to be 36, 0.9 times 4, it's going to be 36, and uppercase N is going to be 20 times, has to be greater than 20 times N. Let's see, 20 times 40, we are getting population, it's not given, so we can find out that one. Okay, 0.9 times 40, yeah. And what else? N minus p hat, N times Q also has to be greater equal 10. So if p is 0.9, then Q is going to be 0.1, right? So 0.1 times 40, it's 4. It's not passing 10, therefore we cannot use normal distribution. So in this case, out of 3 conditions, the 2 is working, 1 is not working. That is N times 1 minus P. Because 1 minus P is 0.1, you multiply by 40, you get 4. Therefore, it is not gonna work normal distribution. Okay, moving to next one, find the T critical for confidence level 0.9. N is equal 6. Okay, T critical, we are going to critical level 0.9, which means 0.1. Okay, for one tail, and instead of 6 we take 1, and we are getting 0.1, 1.47, it was 6, right? Yeah, 6 and 0.90, so it's going to be one tail 0.1 or T 0.9. If you look above 0.1, it's 0.9. See that? Okay, so for the degree of freedom 5, we are getting 1.476. Okay, let me write down. .476. Okay, and question number 13. Find the Z critical that corresponds to 90% level confidence, that corresponds to a 90% confidence level. Okay, so this time we are going to Z critical. Since our percentage is 90%, that means alpha going to be 0.1, and since we are going to take 2 tail, 0.1, I'm typing here 0.1 and click calculate 0.1, and I'm getting 1.645. 1.645, and we are done. All right. Submitting quiz. Well, 10 unanswers. Those are the ones I already recorded. So we go from backwards, right? The ones we answered. Let's see what's happening. Yeah, number 10 I didn't answer anymore. I started solving from number 11, so up to 11 it was everything all right. We solved it, but let's check here. We have number 12 is wrong. And it's far away from the answer. Let's double check again. Maybe I didn't go to the right number. 0.9 and N is 6. Okay. 0.9, that means for the alpha will be 10. Oh, I didn't divide by 2, 0.05. Okay, one tail 0.05, and we are taking 5, and that's how we get here. It is 2.015. Okay, the mistake I made, I didn't divide. I got one tail, and it usually, when it's giving you, it doesn't mention how many tails. You use 2 tails, which means 0.10, it's a 1 tail, and I took it, but it's a 2 tail, and I have to divide by 2, get 0.05. And with degree of freedom degree of freedom 5 and 0.05, we are getting 2.015. Okay, so this is supposed to be 2.015. There we go, and its answer here is correct. Okay, I am done. I believe I recorded all videos. I should. If I forgot something, please text me or email me, let me know, and I will record it. And as always, contact me if you have any questions. Okie dokie. Bye.